Hello and welcome. My name is Sally Moreno and you are in my channel Embedded Soul. I'm an electronic engineer and develop C-language programming focused on embedded systems. And this channel has been created to share knowledge about this topic. I hope you enjoy the content and please leave your comments. But don't forget to click on the like button if you like this video and subscribe if you like this channel. Thank you for watching. Hello and welcome to another video. In this video, I'm going to talk about some theory about function pointers. I'm going to share the screen. Yeah. Okay. This is my channel, Embedded Soul. Now I'm going to talk about a C-language topic called function pointers. We'll talk about theory and its implementation. Okay, theory. When we define a function in C language, the name of the function is like the name of an array, in the way that the name of the function is a pointer or keeps the address to the beginning of the code of the function. It means when we define a function, its name is like a pointer. It keeps the address to the beginning of that function. So invoking a function tells the program where it has to jump. Okay, because the function itself, the name itself, is a pointer. It gives an address. We can declare a pointer to a function called function pointer, but in the same way, when we declare any pointer, we have to say to the compiler what kind of variable are pointed to. Okay, when we declare a function pointer, we have to say A is a function, a pointer that points at a function with this inputs, with these parameters, and this outputs, because the compiler needs to know the size of the bytes that this pointer points to. The syntax is variable type. It means the variable, sorry. The name of the output variable, the type of the output variable. Between parentheses is very important. Between parentheses, we have to put asterisk because it's a pointer. The name of the function, the name we have to give to the function pointer, and then inside parentheses, the different variables that the function pointer takes as parameters. We can save time using typedef statements. Instead to type anytime, we have to declare a function pointer with of this type. We can instead type anytime the same. We can define a typedef variable to create an alias to type less text to say the same. We can say typedef variable type, parentheses, asterisk, name of the function pointer, parentheses, and open parentheses, and the variable types we need as parameters. Okay, so we can declare our function pointer as name of the function pointer. It's this name created before. Pointer my function equals the address or my function that is an address. This is the function, the real function we have created and this is the pointer that will keep the address to that function. Okay, let's continue. Example, int my function, int x is the function declaration my function. Type def int asterisk int int is the function pointer declaration. And here I'm telling the compiler this keyword int is equal to say to say all this function pointer declaration. Okay, we can save time, save typing using type def. And I'm going to declare a function pointer of this type called my my function equals ampersand my function. Okay, the ampersand is not necessary to set because only my function means the address of that function, but it's a good practice to put the ampersand because it gave us a clue what's happening, what we are doing. Okay, it assigns the address of the function to the function pointer. So we can create a variable called output equals to my function pointer with the input variable and get the result. Okay. Before I said it's very, it's strongly, it's an obligation to put parentheses between the name of the function pointer, because if we don't do this, the compiler can think that instead of function pointer, it's a function declaration that has an output variable type pointer to integer. Instead of function pointer, pointer to integer. So it could be the compiler can understand or can misunderstand. Instead to be a function pointer, be a regular function that takes a pointer to integer as an output. Okay, it's very important, the parenthesis here. Uses of function pointers. Function pointers are very useful to point to different functions with the same parameters. I mean, we have many functions with the same parameters, with the same type of parameters and outputs. We can reference all of them using a function pointer defined with the same parameters. We can declare an array function pointers. We can declare an array of function pointers to invoke different functions depending the selected index of the array. Okay, we can have an array of function pointers, and using the index of that array, we can invoke different functions. So only changing the index, we can change the function being invoked. Okay, we can declare structure of function pointers to create methods inside classes. Okay, sometimes we have like, for example, a driver, and we have to get in order to be organized our functions inside a group. This group is going to be called a class. Inside the class are going to be our methods, and our methods are all this group of functions. So invoking the structure and this their function pointers inside it, we can control all the driver. We won't have spread functions over where we will have our functions grouped. So it's very useful to create classes and methods to have organized our drivers. We can create callbacks functions to be passed to all the functions as reference. Okay, function pointers are pointers, and we can pass as parameters or arguments to other functions. And then these functions passed to other functions as parameters receive the name of callbacks, because in the future, once we have invoked our function and passed the function pointer as parameters, the callback is going to be invoked in the future, is going to be invoked back. Okay, we can use pointers as function pointers as pointers. Advantages of using function pointers. It extends the concept of using pointers to point to functions instead of variables. Okay, the same powerful concept using for variables, when we use pointers to variables, we can get the same powerful structure, the same powerful concept applied to functions instead of variables. It gives us more flexibility to execute different functions changing the pointer. And we can have the same code, and without changing our code, only changing the address and say the function pointer, we can't execute different functions. It gives us a lot of flexibility working with functions. It gives us a more complex programming structure to solve more complicated problems. Okay, it's obvious. Disadvantages of using function pointers. It needs us to define the function pointer. We have to define function pointers. We have to code more, type more code. It needs us to assign the address to the functions pointers. Okay, the function pointers have to know the address to point to the function to be invoked. It needs us to manage pointers. Obviously, when we have pointers, we have to take care of them and manage them in the right way, because in another way, they won't work. Okay, in the next videos, we'll see some examples using code blocks or other ideas. And finally, I provide some videos, some demonstrations using my examples of function pointers inside a microcontroller. I hope this video has been useful for you. Please let your comments, and thank you for watching.